determine algebraically. So this is telling us again, wow, I'm struggling with the switch. Too close to the top, I guess. X and Y. And solve for Y. That would be the algebraic way to see if two things are inverses of each other. So, if I switch X and Y with one of them, I rearrange and I get the other equation, that would tell me that they're inverses. If I switch X and Y and rearrange, and I can definitively say, no, they are different, then they will not be inverses. So let's look at part up. If I start with Y equals 3X minus 6, I do the switch, I would get X equals 3Y minus 6. I want to get Y by itself, so I'm going to add 6 to both sides. Divide everything by 3, which will get Y by itself, and I'll get X plus 6 over 3. It's close. Okay. Are they the same? Is there any way you're allowed to mathematically just change a plus sign to a minus sign? No. Not just decide, oh, I just want to change my plus sign to a minus sign. So no, these are, as a result, they are not inverses. First one, straight line, no problem. Okay, second one. A couple of things to point out in the second one. We have y equals negative x squared plus 3. That should be fairly okay, but then right after, they have this extra stuff. What is that extra stuff? Domain. That's the domain restriction. So what this is telling us, we would normally have a parabola. That parabola would be flipped vertically and then shifted up 3. But then you're only going to take half of it. Based on the half that you take, is this the right equation or the wrong equation for that half? That's what we're going to try to find out. So, we're going to do the switch. I'm not going to rewrite it. I'm just going to add an arrow. Oops. X equals negative y squared plus 3. Personally here, I'd probably see that this y squared is negative. I would move that to this side, and I would move my x to this side by subtracting. So y squared equals 3 minus x. So getting y by itself would be plus or minus 3 minus x. I have to find out, how do I know if it should be the plus or the minus based on the domain restriction? Again, everything switches. So this domain restriction becomes a range restriction on the inverse that y has to be bigger than or equal to 0. And now it almost becomes obvious. Should it be the plus or the minus if it has to be bigger than 0? Yes.
Wait, why did the x start on that side this time?
Okay, so the original equation was, I didn't rewrite the original equation. There's our original equation from up here. The very first step in algebra finding the inverse is switching the x and y. So I just switched it right away. That's why I put the arrow from switch, because I'm trying to be fine line. Efficient was the word I wanted to say, right? Sometimes it comes across as lazy, because I'm not writing something again. But I think efficient is good. But sometimes mathematicians become so efficient that it seems like they're becoming lazy. Because they're like, oh, I don't want to write whole words anymore. We abbreviate everything. Like, what kind of crazy English teacher created the word centimeter? It's so long. We'll just do C and M. There we go. We never have to learn how to spell it in our lives. Perfect. You can abbreviate everything. We're already horizontal compression. Oh yeah, just HC. That'll be. Are we lazy, or is that efficient? Efficient. So there are other lazy people here who agree with me that it is efficient. Excellent.
I think you mean other efficient people here.
Are lazy? Okay. So it has to be, if y is bigger than or equal to 0, it has to be the positive one. Does that match up? Yes. Question? Mm-hmm. So if we have a domain restriction, when we switch it, we'll have a range restriction.
On a test, let's say we're just trying to be efficient, do we need to write plus or minus, or can we just
Yes.
do the next one even though we know?
Yes. So that's a good question. If you already know you have to show something, and there are certain parts on the provincial exam where they say you do have to show the plus or minus, even if you know already it's going to be the plus one. Because they don't want to put the teacher into a place where they're being subjective, where they're saying, oh, they didn't write the plus or minus, but I know Talia. She would have got that right. I'll give her full marks. And then the next day, oh, someone else didn't put the plus or minus? Like they knew what they were doing. I'm taking off a mark. So now we can't make that assumption based on that. So we have to always show all of our work to really say, yes, I know that it's there. There are some really, there's a couple of obvious places where if you don't show the work, when they come up, I'll show you more examples of things you have to show your work. And
With factoring, we don't.
yeah, factoring, there's sometimes where you see something's a non-permissible value, you still have to write the answer down and then put an X through it. Instead of just not writing it down and going, I could already see that it wasn't gonna work. But we'll get to that. So graphically, I'm not gonna do the first one, I will look at the second one graphically. So the second one graphically, we had a parabola, negative x squared plus 3, so that parabola would be flipped, then shifted up 3 units. This would be the entire parabola, but we're only thinking about the purple side, because x is bigger than or equal to 1. And it would have the point 0, 3, 1, 2, and so on. Then graphically, and I'll do it in green, if I want to graph this, I'm going to have to do some manipulation in order to graph it. First manipulation is that 3 minus x is the same as minus x plus 3. But we always did the x's first and the numbers after. So now this is in our mode of, oh, I have a horizontal reflection and a horizontal translation. Okay? Secondly, it's not in factored form. So if I want to use my strategies, I'm going to take my square root, which looks like this. Then I have a horizontal reflection, which looks like this. And then I'm going to move it 3 to the right, which looks like this. How did it disappear? I make it disappear.
It's magic.
It's magic, yeah. Technically, I could make it disappear if I, since we're talking about magic, use the magic pen. Look at that, there's a magic pen. Hi. Okay, it doesn't talk. But it does disappear. Other things the magic pen can do is the magic pen can make things bigger sometimes. But not in this case. Might be the new update. Oh,
You lied. It
it
did.
did make it bigger. Just dramatically slow. I think it can also do something like that. Oh. Black it out. Also, this new update is dramatically slow. Okay. So I made my own. I like the invisible pen, but I don't like if I accidentally make a circle, it blacking out everything. So I made my own custom invisible pen in the top right-hand corner. And I decided, I think, 5 or 4? 4, 3, 2, 1. Maybe 5. Maybe I'm not on the magic pen anymore. It looks like I'm not. At all. That was disappointing. We'll try 4 seconds if I actually click on it. 4, 3, 2, 1.
But if you make a circle, it won't.
Yeah, now we can just. Circles also take 4 seconds to disappear.
Wow.
There are some things that the magic pen doesn't work. 1, 2, 3, 4. Oh, she's kidding. You can't make students disappear.
You wanted to make her disappear?
No. All right. Questions. We're not going to do the graph on the other one. I'm going to give you questions for practice. 7. I have 7, 8, 11, and 13, and I put stars beside 11 and 13, which means they're probably a little bit of problem-solving questions. So if you try them. If you get stuck, don't worry too much, but do come in and ask questions.